For nearly a century, a simple, nearly free method of generating electricity has existed, capable of being built in a weekend using junkyard scraps. It is known as the Savonius rotor, a vertical-axis wind turbine that can capture wind from any direction and survive brutal weather. Yet, if you try to put one in your backyard today, you will likely run headfirst into a wall of bureaucracy. The sources provided for this script do not contain evidence of a deliberate government conspiracy designed to force residential grid dependency. However, the sources do extensively document a massive labyrinth of zoning laws, homeowners association regulations, and utility interconnection roadblocks that effectively squash small residential wind projects before they even start. The core physics of this design actually traces back to 1924, invented by Finnish architect and engineer Sigurd Johannes Savonius. At the time, Savonius was studying the Magnus effect alongside German engineer Anton Flettner, who was testing massive spinning cylindrical sails to propel ships. Savonius wondered if a rotor could operate entirely on wind power without the aid of an engine. By slicing a cylinder in half and offsetting the two vanes, he created a vertical-axis wind turbine that produced high rotational torque. Unlike the massive modern horizontal-axis turbines that rely on complex aerodynamic lift, the Savonius design operates primarily on drag. One side of the offset cylinder catches the wind and creates more drag than the opposite side, forcing the central shaft to spin. The brilliance of the Savonius design is its rugged simplicity. It accepts wind from any direction without needing a tail or yaw mechanism to track the breeze, making it highly reliable and incredibly easy to maintain. But the real magic happens when people realize they don't need expensive composite materials to build it. They just need trash. Since the 1970s, DIY enthusiasts and off-grid builders have been constructing their own Savonius turbines using simple, inexpensive materials. The most iconic design relies on food-grade 55-gallon plastic or steel drums. To build one, a maker carefully draws bisecting lines across the top and bottom of the barrels using a compass. The barrels are cut in half while avoiding the thick seams and spouts. The two halves are then overlapped by about 9 inches to form an S shape. These halves are firmly bolted together with quarter-inch nuts and bolts, and a thick-walled 3-inch PVC pipe is driven through the center to serve as the structural axle. To allow the turbine to spin freely, builders fabricate bearing assemblies using Lazy Susan bearings mounted on heavily varnished wooden planks. Some engineers prefer salvaging automobile brake discs from junkyards because they provide extremely strong, low-friction tapered roller bearings that can last for decades while also acting as a flywheel to smooth the turbine's rotation. Once mounted, this spinning collection of recycled parts is connected to a salvaged automotive alternator using a gear, belt, or chain drive. Under normal conditions, the system can generate between 60 and 100 watts of instantaneous power, enough to charge a marine battery or run lights and a laptop in an off-grid cabin. This concept isn't simply a relic from the 1970s. Recently, researchers at Bielefeld University of Applied Sciences designed a DIY Savonius turbine as a public educational project for the circular economy, demonstrating that it could be built for less than €65. They salvaged wooden pallets from a university junkyard, breaking them apart with a crowbar to construct a sturdy 140-centimeter-tall lattice tower. For the rotor, they cut up old metal shelves and attached them to S-shaped wooden battens. Instead of a heavy car alternator, they utilized an old 26-inch bicycle rim fitted with a Shimano DH3N20 gearless hub dynamo. By hooking the dynamo to a chemoelectronics charge controller, they created a system capable of outputting a steady 1.5 watts of direct current via USB. Even though 1.5 watts is tiny, taking roughly 52 hours to fully charge a 12,000 milliamp-hour power bank, it proves a critical point. anyone, anywhere, can generate their own electricity using discarded junk. So if generating power from scrap is so easy, why doesn't every house have a spinning barrel on the roof? This is where the dream of decentralized free electricity hits the harsh reality of local zoning and utility monopolies. While there is no overarching federal ban preventing you from erecting a wind turbine, local zoning boards and utility companies have established severe barriers. The government states that these regulations are intended to address safety, visual aesthetics, and community interests, but the result is a gauntlet of red tape that makes residential wind power exceptionally difficult and expensive to deploy. Let's start with local zoning. The single most important factor for wind energy is height. A turbine needs to be at least 30 feet above any obstacle within a 300-foot radius to escape ground turbulence. However, the vast majority of local zoning ordinances impose a strict height limit of 35 feet for residential structures. To build a tower high enough to actually catch decent wind, you must undergo a special review process to obtain a zoning variance. This process is highly uncertain, demands public hearings, requires expensive engineering surveys, and has no guarantee of success. If you somehow get a height variance, you then face setback laws. Many jurisdictions demand that a wind turbine be set back from all property lines and adjacent structures by a distance of 1.1 to 2 times its overall height. If you build a 60-foot tower, you might need 120 feet of clearance in every direction. This single regulation immediately bans wind turbines from virtually all suburban residential lots. And if you clear the setbacks, get ready for the noise and aesthetic compliance tests. You must hire a qualified acoustical engineer to prove your turbine complies with strict noise limits, which are often capped at an aggressive 50 decibels at the property line in residential areas. Furthermore, some towns require applicants to prove that the rotating blades will not cause a shadow flicker nuisance on neighboring properties, placing the entire burden of proof and the cost of mitigation squarely on the homeowner. If you plan to eventually take the turbine down, several jurisdictions force you to hire an independent engineer to calculate the cost of decommissioning it. The town may then require you to post a financial surety bond of up to 150% of that removal cost before they even issue your building permit, just in case you abandon the project.
But let's say you live in an unincorporated rural area with relaxed zoning. You're still not in the clear. If you live in a modern subdivision, your homeowners association, HOA, likely prohibits them entirely. Because turbines are highly visible, HOAs routinely block them to protect curb appeal and enforce uniform roof lines, threatening fines or even property liens against homeowners who install them. The final boss of the red tape labyrinth is your local electric utility company. If you want to connect your scrap-built turbine to your home's electrical panel while still using the grid for backup power, you must sign an interconnection agreement. Utilities have legitimate safety concerns. They need to ensure your homemade turbine automatically shuts off during a blackout so it doesn't feed live electricity back into the grid and endanger line workers. However, utilities often use this safety requirement to impose expensive financial conditions on homeowners. Some utility companies require owners of small wind turbines to carry liability insurance policies worth $1 million or more to protect the utility from potential damages. Others require broad indemnification agreements that heavily favor the power company. Some even charge discriminatory standby fees or metering fees simply because your generator remains connected to the electrical grid. If the insurance requirements or utility fees become too expensive, your DIY wind project will never recover its cost, forcing you to abandon the idea altogether and continue buying electricity from the utility. The physics behind the 100-year-old Savonius wind turbine is proven, simple, and accessible to everyone. Anyone with a few discarded barrels, a length of PVC pipe, and a salvaged automotive alternator can harness the power of the wind. But the reality of modern residential construction is heavily regulated.
between 35-foot height limits, 50 decibel noise restrictions, property setback requirements, HOA aesthetic rules, and $1 million utility insurance requirements, the system creates enormous obstacles for anyone attempting to generate their own electricity. It may not be a deliberate government conspiracy to force dependence on the electrical grid, but the sheer weight of zoning laws, permitting requirements, HOA restrictions, and utility regulations ensures that for most Americans, staying connected to the grid remains the only practical option.